Hello everyone. In this video, we are going to learn light, reflection and refraction, which is there for CBSE 10 and state 10. In this video, we will focus mainly on reflection of light. So please watch the video till the end. You will understand each and every concepts. What are the concepts we are going to cover? First, you should know what is light. Okay. Then reflection of light, laws of reflection, then real image and virtual image, image formed by the plane mirror. Okay, then we will move to the spherical mirror, that is concave mirror and convex mirror. Then rules of image formation. After that, image formed by the concave mirror, convex mirror, sign convention. After that, mirror formula, magnification of mirror. And last, we will take problems. Okay, so let's start. First points, light. When we talk about light, light is a form of energy which enables us to see an object. Yes or no? So we are able to see anything because of light. So the concept is what? Whenever light falls on the object and after reflection, it reaches to our eyes. And where is the image formed? Image is formed actually at the retina. And at the retina, we have optic nerves that will take the signal to the brain. Okay. So light is there. We talk about the ray of light. What do you mean by ray of light? It is actually a concept, sir, which indicates the direction of propagation of light. If it is like this, ray of light, it means the light is traveling in this direction. If it is like this, light is traveling in this direction. If it is like this, the light is traveling in this direction. Yes or no? We talk about beam of light. A group of light ray is called as beam of light. Okay, so it is of three types, sir. One is parallel, then convergent and divergent. Parallel beam of light ray means if the light rays will not meet at any point. So they are parallel beam of light. Convergent means if they will meet at any point. So no, that is convergent. And divergent means like this. Light ray will appear to meet if you produce it backward. Okay, so light ray will appear to meet at this point. So no. Here you can see the definition. Light is a form of energy which enables us to see an object. We talk about reflection of light. What happens when light falls on the surface? It bounces back. This phenomenon of bouncing back of light ray after striking a solid surface is called as reflection of light. Here you can see this is a reflection of light. Mn is a mirror, AB is incident. Okay, AB is an incident on this mirror. So light ray will reflect back in this direction. So AB is called as incident ray, BC is called as reflected ray. If you draw a 90-degree line at this point B, okay, that is called as normal. Angle made by incident ray with the normal. This angle is called as what? Angle of incidence. We are representing as angle I. And angle made by reflected ray with the normal is called as what? Angle of reflection. We are representing as angle R. So we have two laws of reflection. First is what? The incident ray, the reflected ray, and the normal. Okay, at the point of incidence, all lie on the same plane. So this light ray which is incident, this light ray which is reflected, and this normal all lie on the same plane. Okay, and second is what? The angle of incidence is equal to the angle of reflection. That is, angle I is equal to angle R. Yes or no? Now, when we talk about characteristics of image formed by the plane mirror. Okay, so here I have taken an Mn is a mirror, plane mirror, AB is the object, and image is formed behind the mirror. So what are the characteristics you can remember? First one, it is virtual and erect. It is what? Virtual and erect. First point. Next, the distance of image. Okay, behind the mirror is equal to distance of object in front of it. Suppose this distance is 2 meters, so this distance will be also 2 meters. Next, the size of image is equal to size of object, or height of image is equal to height of object. Suppose this distance is 2 feet, so image distance will be also 2 feet only. Yes or no? And it is laterally inverted. It means the left part of the object, okay, becomes right part of the image, and vice versa. Next, we talk about the what do you mean by real image and virtual image. Okay, try to understand this real image and virtual image. Okay, real image is an image which is formed when the light ray actually meet at a point. You can see here, okay, this light ray and this light ray when they meet at any point. Okay, this point. So, what type of image is formed? A real image is formed. Okay, but when the light ray is not meeting, light rays are not meeting. If they appear to meet, okay, they are diverging right now. So once you bring it backward, yes or no? So you can see here, they will appear to meet at this point. So here virtual image is formed. Okay. Okay, next point. The real images are always inverted, where virtual images are always erect. Real image can be obtained on the screen, whereas virtual image cannot be obtained on the screen. This question may be asked, so you should know. This is very, very important. So whenever the light is actually emitting, so image formed is what? Real image. Okay, these are concepts you should remember. Yes or no? Next, we talk about the spherical mirror. Okay, in a spherical mirror, we have two types. One is what? Uh, Concave mirror, other is convex mirror. See, to understand the spherical mirror, you assume one hollow sphere. Okay, this football is there now. Assume that football is made up of glass. Okay, so this is the sphere I have shown now. Okay, you can cut in the industries, they are cutting like this. If you polish the outer part, okay, if you polish the outer part, okay, polish the outer part, so inner part become what? A reflecting part. This part is polished from outer part. Okay, you can see here. Okay, if you polish from outer part, so this part is a reflecting part. Yes or no? So this is called as what? A concave mirror. Yes or no? And if you polish the inner, so this is the spherical glass you can see. Okay, and then this inner part is polished. Okay, you polish the inner part. Okay, now so if inside if you polish means we can see from this side. So this is called as what? A convex mirror. This is called as what? A convex mirror. See, we have certain terms in the mirror. Okay, like pole, center of curvature, focus, focal length, radius of curvature. So you should understand each and every terms related to the mirror. First, we talk about the center of curvature. This is center of the curvature. Actually, it is the center of a sphere, which is a part of the mirror. Yes or no? Getting up? So this is the center of curvature. The midpoint of the reflecting surface, that is a mirror, is called as P. That is what? A pole. Here you can see the definition first. Okay, aperture. Aperture is what? The width of the reflecting surface from which the reflection takes place. Okay, so you can see here. Okay, if this is a mirror, this is a width. Yes or no? So width is called as what? Or diameter we can say is called as what? Aperture. Next point, pole of the mirror. The central point of the reflecting spherical surface is called as pole. Okay, so you can see here. Okay, this is the spherical mirror, concave mirror. So the midpoint is called as a pole. Is it clear? Next, center of curvature. As I told you, the center of hollow sphere of which a spherical mirror is a part is called as center of curvature. What about the radius of curvature? Okay, the separation between the pole and the center of curvature of the radius is called as radius of curvature or the radius of hollow sphere of which the mirror is a part. You can see here. Okay, this point. This is the actually radius of the sphere of, yes or no, which is a part of the mirror. Yes or no, this is called as what? Radius of curvature, represented as R. Yes or no? If a line passing through the C to P, this line is called as what? A principal axis. The line is called as what? A principal axis. Okay. What happens in case of concave mirror? Okay, if you take let's take a concave mirror here. One second, I will draw. Okay, outer part is polished. It is a concave mirror. Yes or no? So this is the line which is the called as principal axis. Here P is there. Okay, this line, this is the C. Let's say this is the C. C is the center of curvature. If any ray of light is parallel to the principal axis, after reflection, it will pass through the one point. Okay, this point is called as focus. And the distance between P to F, this distance is called as focal length, represented as small f. This distance between P to C, this is called as what? A radius of curvature. I hope you understood this. Okay, in case of diverging the mirror, you can see. Okay, if I draw a diverging mirror, that is diverging mirror in the sense means convex mirror. Okay, let's take a principal axis. Okay, this is P. P will be that midpoint. Okay, now this is the center of curvature. Inner part is polished. Yes or no? That is what the convex. If any ray of light, this line is called as what? Principal axis. If any ray of light which is parallel to the principal axis, after reflection, it will diverge. It will appear to pass through one point. That point is called as what? A focus. That point is called as what? A focus. Here also you can see the PF distance is what? Focal length, and the PC distance is what? A Radius of curvature. Actually, radius of curvature is equal to 2 times of focal length. Small r capital R into 2 times of focal length. Yes or no? So PF is equal to what? Focal length. Okay, and PC is equal to radius of curvature. Radius of this distance is what? Twice of this distance. Yes or no? Okay. So this definition you should remember. Next definition, like principal axis, the straight line joining the pole and the center of curvature is called as principal axis. Focus, how will you define the focus? The point on the principal axis where the beam of light parallel to the principal axis actually meet after reflection in case of concave mirror or appear to come from, okay, in case of convex mirror is called as what? The principal axis. We talk about focal length. Okay, the length or the separation between the pole and the focus is called as focal length. Definition you can remember. Relationship between the radius of curvature and the focal length. Radius of curvature is equal to what? 2 times of focal length. Yes or no? Now coming to the rules of image formation, which is very important. Okay, we'll see for concave mirror as well as convex mirror. So let's take a rule number 1. Okay, this is a convex mirror, sorry, concave mirror. Here outer part is polished, you can see. What is the first rule? If any ray of light which is parallel to the principal axis, after reflection it always passes through the focus. This is the first rule. In case of concave mirror, in case of convex mirror, this is a convex mirror, inner part is polished, yes or no? If any ray of light is parallel to the principal axis, after reflection it will diverge, it will appear to pass through the point of focus. Rule number 2. Okay, if a ray of light is directed towards the focus, okay, passing through the focus, after reflection it becomes parallel. Here, if a ray of light is directed towards the focus, after reflection it becomes parallel. Okay, and here if the ray of light is passing through the focus, after reflection it becomes parallel. Rule number 3. If any ray of light which is passing through the center of curvature, okay, will bounce back. If it is coming like this, it will bounce back. Here, if the ray of light is directed towards the center of curvature, you can see, so it will bounce back. Why? Because here, if any ray of light which is passing through the C, okay, it is acting normally on the spherical mirror. That's why it will bounce back. Okay, and rule number 4 is what? If a ray of light is incident at the pole obliquely, so it will also reflect obliquely. Okay, and angle will be same. Suppose this is 30 degree means this will be also 30 degree. Here also, if it is incident obliquely means it will reflect obliquely. So these rules are very important. Okay, if you remember the rules, then only you can form the image. Okay, by the spherical mirror. Let's talk about the image formation by concave mirror first. Concave mirror. We will keep the object at different places and we will see where is the image formed. So first by concave mirror, image formation by concave mirror. Let's take this is a concave mirror. Okay, object is where? Object is at infinity. Okay, from the infinite objects, whenever the object is placed at infinity, the light ray will come parallelly. You can see the light ray is coming parallelly. So you know that when ray of light is parallel to the principal axis, okay, after reflection, what will happen? It will pass through focus. Okay, this will also pass through focus. These two light ray will meet at the focus. So you know when the light ray is meeting, their only image is formed. So what is the position of image? Position of image is at the focus. And how is the nature of image? Obviously, it is real, inverted and point size. Also we can say highly diminished. Next case, when the object is beyond C. Okay, this is the center of curvature. Okay, so here object is beyond C. AB is the object. So one light ray you take a parallel, it will pass through focus. Yes or no? This is the focus, it will pass through focus. Next you pass through the focus. Okay, this light ray is passing through focus. After reflection, what will happen? It will become parallel. So you can see this light ray and this light ray is meeting here. So image is what? A dash, B dash. So where is the position of image? Between C and F. Between C and F. Okay, this is it. How is the nature of image? Real, inverted and diminished. Next we talk about whenever the object is at center of curvature. AB is the object. Okay, AB is the object. So one light ray you take parallel, it will pass through focus, yes or no? Second you pass through focus only. So it will become parallel. So you can see this light ray and this light ray is meeting beyond where? Exactly at the C only here. Okay, so here only A dash, B dash image is formed. So image is at C only, and then how is the nature? Real, inverted and same size. Now when we take the object between C and F, Okay, here AB is the object. One light ray you take parallel, it pass through focus. Yes or no? Second, you pass through the focus, so it will become parallel. Now, as you can see here, this light ray and this light ray is meeting where? Beyond C. So, image is found beyond C. It is real, inverted, and magnified, or also you can say enlarged. Yes or no? Next, when the object is at focus, okay, here is the object, AB is the object at focus. So one letter you take parallel, it passes through focus, yes or no? Second, you incident it obliquely, so it will reflect obliquely. You can see they are actually seems to be parallel and they will meet where at infinity, somewhere at infinity. Okay, really, what will be the nature? Real, inverted, and highly magnified. Yes or no? Next, whenever the object is between focus and the pole, you can see this point is what focus and this point is what a pole. So here object is there. AB is the object. So here one light you take parallel, it will pass through the focus. Yes or no? Second, you incident obliquely, so it will reflect obliquely only. Now this light ray will be what diverging. Will they meet? They cannot meet this side. In this case, if you produce it backward, so they will appear to meet. So no, behind the mirror. So image is found A dash B dash behind the mirror. It is what a virtual, erect, and magnified. In this case only, the image is virtual and erect when the object is between focus and the pole. Remaining all the cases, image is real. So no, and inverted. Now, where we are using concave mirror, this question may be asked for 2 marks. Okay, so because of its nature, that is converging nature, it is used as a saving mirror. It also forms what enlarged image. Yes or no? Concave mirror forms enlarged image. So this property of the mirror is used as a saving mirror. It is also used as a reflector to concentrate light. Because when a beam of light is parallel to the principal axis, after reflection it will meet at one point. So it is used to concentrate beam of light. In the sense means suppose if a ray of light is here, this is a mirror. Many light rays are passing through the focus actually. So what will happen? It will become parallel. So no. So that is one property. Other property what will enter if the ray of light is parallel. Okay. So what will happen after reflection? It will meet at one point. So light rays are concentrated to one point. Next, in case of searchlight headlights of automobiles, it is used by the dentist to observe the cavities in the teeth. Okay, to get the enlarged image of the cavities. Okay, this sign convention is very important called as new Cartesian sign convention. Okay, so what is this? It is a set of rules to use a positive or negative sign. Okay, with the values while doing any problems. We will apply the sign convention in case of spherical mirror, concave mirror, and convex mirror. First, I have shown for concave mirror here. Outer part is polished, so you can consider this any one axis which is perpendicular. Is what y dash. This is what x dash. P is what pole. Here, what happens very important. All the distances are measured from the pole. Okay, distances in the direction along the incident light. This is the incident light. So distances in the direction along the incident light is taken as what positive. Okay, distances against the incident light is taken as what negative. This is the principal axis right now. So height above the principal axis is taken as positive, and height below the principal axis is taken as negative. That you have to remember. You have to apply the sign convention in always the known quantities. We are generally not applying the sign convention in the unknown quantities. You will see while solving the numericals. Now, coming to the image formation by a convex mirror. Okay, so here only 2 cases are there. This is a convex mirror. Okay, you take the object at infinity. Where is the object? Here, I have taken one object at infinity. So you have to take at least 2 light rays. Okay, parallel, yes or no? So what will happen? If a ray of light is parallel, it will diverge, yes or no? It will appear to meet at a point. Consider this. Okay. Okay, so you can see if the ray of light is parallel, it will appear to pass through focus. Here, same. If the ray of light is parallel, it will appear to pass through focus. So here only they will meet. Okay, na? They will actually appear to meet. So where is the position of image? At the focus. At the focus. And how is the nature? It is virtual image. How it is it is virtual. Okay, director, virtual image are always director and point size or highly diminished they are saying. Next, take the object between infinity and the pole. Okay, here we are taking the object between infinity and the pole. This is the pole. Yes or no? This is the pole. So you have to take two light ray. Yes or no? So at least you take parallel. So what will happen? It will appear to pass through focus. Yes or no? So you can see here. Yes or no? So this is the light ray is going parallel. It will appear to pass through focus. This is the focus point. You can see. Okay, here is the center of curvature. You can consider this as center of curvature. Okay, so if and another rule we follow. If ray of light is directed towards C, okay, this is a directed towards C. Okay, center of curvature you can see. Okay, na? If a ray of light is what directed towards C, so what will happen? It will bounce back. So you can see this light ray and this light ray will appear to meet here. So here only virtual image is formed. Okay, A dash B dash image. Okay, of the object A B. So in this case, where is the image formed? Behind the mirror, obviously. Behind the mirror. Behind the mirror. Okay, where? Between P and C. Okay, what will be the nature? It is a virtual image. Virtual image are always erector or upright, we can say, and a diminished only. The image is what? Diminished. Yes or no? Only two cases are there. Now, next we talk about the uses of convex mirror. Here we are using a convex mirror. Okay, so uses of convex mirror, it is used as a rear view mirror. Then I ask you why? Because it gives a wider field of view. Okay, now as the mirror is curved outward, it forms a very diminished image. Yes or no? And it produces erect and diminished image of the traffic behind the driver of the vehicle. That is the reason we are using as a rear view mirror. Next, it is used as a device to check the thefts in the shop. They used to use as a device to check thefts in the shops, especially in the jewelry shops. Okay, big showrooms it is used. It is also used to bring the view of corner which are not directly visible, and it is used to lighten a large area, larger area. Okay, so these are the usage you have to remember. Here we talk about the sign convention in case of convex mirror. So this is the convex mirror. All the distances are measured from the pole. Distance right to the pole is taken as positive or in the direction of incident light. Opposite to the direction of incident light is taken as negative. Upward height is taken as positive and downward height is taken as negative. Now, very important, numericals will be asked based on this. What is mirror formula? It is a relationship between U, V and F. What is U? U is the object distance. What is V? V is the image distance and F is the focal length. The formula is like this: 1 by V plus 1 by U is equal to 1 by F. Where U is what? Object distance, V is image distance and F is focal length. We talk about magnification of the mirror. Okay, it is defined as the ratio of size of the image to the size of the object. Okay, so we are writing the height of the image to the height of objects. M is equal to height of image by height of object. Okay, height of image hi, height of object h0. It is also related with the image distance and object distance. How? Negative of v by u. Image distance, negative of image distance by object distance. So this is the formula you can remember overall. Magnification is hi by h0 or is equal to minus v by u. Okay, when you solve the numericals, we will get a magnification has three values. Okay, three values is possible. Magnification may be greater than 1. In this case, the image is enlarged, obviously. When height of image is more than height of object, then only we will get m more than 1. So image is enlarged. If magnification is less than 1, it means image is diminished. And if magnification is equal to 1, means image is of same size as that of the object. Okay, let's take one problems. Okay, there is one numerical. And security mirror is used in big showroom and has radius of curvature 5 meters. Security mirror, which kind of mirror it is? Obviously convex mirror. Yes or no? Convex mirror. Okay, radius of curvature is given how much? 5 meter. Okay, so convex mirror, you know how is the convex mirror? Okay, you can draw one rough diagram also. Okay, so here polished part is what? Inside part. So separative mirror used in the big showroom has a radius of curvature, okay, 5 meter. Where is the radius of curvature? Okay, here C is there, so radius of curvature on the right hand side. So it is what? Positive. Yes or no? That you have to remember. If the customer is standing at a distance of 20 meter from the gas counter where the mirror is actually there, find the position, nature and size of the image. So they have given U. U is how much? Minus 20 meter. Why? Because U will be on the left hand side of the mirror. Yes or no? So U is what? The customer is standing here. Suppose this is the customer standing. Okay, at a distance of what? 20 meter. Positive or negative? Obviously negative. Why? Because okay, U we are considering on the left hand side of the pole. Yes or no? So that is negative. Okay, what about the radius of curvature on the right hand side? Okay, yes or no? So right hand is going like this, na? So we are taking the distance in the direction of incident light. This is what radius of curvature. So what is the focal length? The focal length is equal to radius of curvature by 2. So what we can write? Pi by 2 minus. So no, focal length, sorry, minus or plus? Plus only. Because focal length is also on the right hand side. So focal length is what? Pi by 2. So U is given and F is given. They are asking, okay, where is the image form? V they are asking. What is V? Okay. So apply the formula. What is the mirror formula? Then solve by using the mirror formula. Okay, what is that? 1 by V plus 1 by U is equal to 1 by F. Okay, so we can write 1 by V. What is U? U is what? Minus 20. Yes or no? U is what? Minus 20. Which sign you have to? Okay, here V, do not apply the sign convention for V. Okay, what is F? Here F is positive or negative? Positive plus 5. 2 will go to the numerator. Yes or no? Then solve it. So we can write 1 by V. Plus into minus will go what? Minus 1 by 20 is equal to what? 2 will go upper, so it is what? 2 by 5. Yes or no? So we can move this to the right hand side. 1 by V is equal to 2 by 5 plus 1 by 20. We can solve easily this one. LCM is what? 20. 20 divided by 5 will get 4. 4 into 2. That is 8. 20 divided by 20 will get 1. 1 into 1. That is 1. So 4 to the 8 plus 1. 9 by 20. Yes or no? So we are going to get 1 by V is equal to 9 by 20. Yes or no? So what is the value of V? 20 by 9 meter. Okay. If you solve this, you will get a 2.2 approximately meter. Yes or no? So image will be formed 2.2 meter. So V is positive obviously. Yes or no? So you know that image is formed yes, virtual image. So how will the image? What is the magnification? Magnification is equal to what? Minus of V by U. So V, how much we are getting actually? You can take this value only. So 20 by 9. And what is the U? U we have minus 20. Yes or no? Minus 20. Okay, so sign convention we are applying. So minus minus get a plus. So we are writing that 20 upon 9 into 1 by 20. 1 upon 9. 1 upon 9. Yes or no? 1 upon 9 is what? Less than 1. Yes or no? So it is what? 0.11 something will come. So magnification is less than 1. So obviously it is what? Virtual, erect and diminished. Virtual, erect and diminished. Like that you can try the problems of concave mirror also. I hope you understood each and every concepts. I tried to clear each and every concepts. If you have doubt, you can write in the comment section. Okay. Please share this video with your friends and don't forget to subscribe the channel. Thank you.